Variable Air Volume Diffusers. Welcome to the Variable Air Volume Diffusers section of the Price Training Module. In this unit, we'll learn how Price's line of VAV air distribution products can help you provide superior comfort and control for your occupants. Conventional systems typically group several rooms into a zone which is controlled by a single thermostat. Because every room within the zone can have different heating and cooling requirements, the result is a system that compromises the comfort of the occupants in each room with a blanket response to individual needs. Price VAV diffusers, on the other hand, are self-modulating, which means they monitor individual space conditions and adjust airflow to satisfy the occupant's selected level of room temperature. The following interactive training module will explore such topics as the concept behind VAV diffusers, their benefits, and how they compare to conventional air distribution systems. We'll look at some operating principles, including pressure control, and learn how to configure buildings with multiple demand zones. Once we understand that, we'll take a look at one of Price's VAV diffusers, such as the Price Varitherm. Concept. What are variable air volume diffusers? A VAV diffuser is a self-modulating diffuser which can monitor individual space conditions and adjust airflow to satisfy the occupant's selected level of comfort. The unique design of the Price VAV diffuser moves an integral damper to vary airflow while maintaining outlet velocities and excellent throw characteristics. The difference between VAV diffusers and conventional diffusers. Here are some characteristics of conventional diffuser system layouts. They have rooms with varying load characteristics, large zone controlled by one thermostat, do not provide individual control. Room with thermostat determines air supply to entire zone. Overcooling or overheating may occur in rooms without thermostat. Terminal units control air volume to each zone. Now, here are some characteristics of a VAV diffuser system using Price Varitherm diffusers. Individual space control and comfort. Air performance maintained at lower flows. Each room receives required air volume. Modular design allows relocation as needs change. Standalone unit provides system flexibility for future requirements. No special training for installation and maintenance is required. As you can see, VAV diffusers offer many advantages over conventional diffusers. We'll take a closer look at these benefits and how they can be credited towards LEED certification in the upcoming section. LEED benefits. VAV diffusers have benefits which can help achieve LEED certification. LEED stands for Leadership in Energy and Environmental Design and is a national standard defined by the U.S. Green Building Council. The program is based on these primary categories: sustainable sites, water efficiency, materials and resources, energy and atmosphere, indoor environmental quality, and innovation and design process. Points and credits are awarded for various items in each of these categories. Buildings are deemed LEED certified buildings if they earn a certain number of points. VAV diffusers can help achieve LEED points in a couple of ways: occupant control and thermal comfort. Occupant control. In order to qualify for this credit, 50% of occupants in non-perimeter spaces must have individual control over the local airflow, temperature, and lighting. VAV diffusers such as the Price Varitherm allow personal control of a zone by letting the user set the temperature set point locally. Thermal comfort. When designing an overhead air distribution system, the location of air outlets must be carefully considered to prevent drafts. With Price's VAV diffusers, supply air is maintained at a high discharge velocity, even at very low flows. This ensures that the Coanda effect is maintained, dumping is avoided, even mixing occurs, and personal comfort is assured. We'll examine this further in the upcoming section. Operating principles. Coanda effect. When the primary air is discharged from the air outlet at high velocities, it creates a negative or low pressure zone to form between the air jet and the ceiling. This low pressure area causes the moving air mass to cling to and flow close to the ceiling surface and is called the Coanda effect or surface effect. The backpan used for the Veritherm series diffusers ensures that the supply air has a smooth transition from the duct to the room. Supply air leaves the diffuser adhering to the ceiling as it flows into the space, delaying the inevitable fall downwards where it mixes with air in the room. The design takes advantage of the Coanda effect by directing the airflow along the ceiling and thereby increasing the throw of the diffuser. To learn more about the Coanda effect, you can check out the Space Air Diffusion and Air Outlet Selection price training modules. Induction. Induction is the phenomenon of air being drawn towards air in motion. As the speed of air movement increases, the static pressure in the zone decreases, pulling the surrounding air towards it. Induction is important to the performance of mixing systems. It's the high-velocity discharge that draws in room air and mixes it with the supply air. A high-performance mixing diffuser will have, among other characteristics, a high discharge velocity. The Price VAV diffusers use this principle to monitor the room temperature from the diffuser plaque. As conditioned air is discharged from the diffuser at high velocities, air within the room is drawn up to the plaque where the integral thermostat can accurately measure the temperature of the room. To learn more about induction, you can check out the Space Air Diffusion Price Training module. ADPI. Equipment can be set up to measure temperatures and velocities at uniformly distributed points in a room. If at each point the draft temperature is within a certain temperature range, and the local velocity is less than 70 feet per minute, then that point meets the comfort criteria. After checking all of these points, an Air Diffusion Performance Index, or ADPI, can be determined. This ADPI value has proven to be a valid single-number rating of an air diffusion system. The Price Veritherm diffuser is designed to maintain a relatively constant ADPI over the full range of movement of their integral dampers. As the damper closes, the air volume discharged from the diffuser is decreased. However, the velocity of the air remains virtually constant due to the resulting reduction in open area created by the damper movement. By maintaining the air velocity, the Veritherm diffuser ensures good induction and mixing of the room air is achieved. To learn more about ADPI, you can check out the Comfort Criteria section of the Price Training module. Temperature measurement. Zone temperatures play a large role in determining thermal comfort. To ensure good thermal comfort, there are three main room temperature control techniques to consider. 1. Thermostats, which provide a control signal to a zone VAV terminal unit. 2. Building automated system signals, which the room thermostat sends to system controls. 3. VAV diffusers with built-in temperature sensors that modulate airflow from the unit's air sensor. Single duct VAV terminal unit. Here, a single duct VAV terminal unit is used to regulate the amount of air supplied into each room. Since there's only one VAV terminal unit, there is only one thermostat. The thermostat signal will determine how much air is supplied during cooling. When the room is warm, more air will be supplied to the diffusers, but a problem arises when the other two rooms without the thermostat don't require cooling. VAV diffusers. With any of the Price VAV diffusers, this problem can be overcome by having control of the supply air in each room. The Price VAV diffusers have built-in thermostats which monitor room air to modulate the flow of air into a space. With this VAV control, the diffuser will throttle to a minimum position when the room does not require cooling. Design considerations, such as layout restrictions and flow characteristics for the VAV diffusers, are the same as those for standard diffusers. Diffuser layouts. Specific rules must be followed when determining the location of a diffuser in an office space so that its performance is maximized and the risk of draft is reduced. The following two examples will examine poor and good diffuser layout. Locating a diffuser inappropriately can result in short-circuiting or the inadequate coverage of cool air, leaving space temperature above or below design. Poor design. 1. Locating a diffuser too close to the wall. Here, the diffuser is in the corner of the room beside two walls. This location results in long throws on the lower left side of the diffuser, which may or may not be the design intent of the room. The diffuser is designed to throw the air along the ceiling for a predetermined distance. Air coming out of the diffuser on the side facing the corner will hit the wall and move downward along it at a high velocity. This may create drafts in the occupied zone. 2. Diffuser spacing. In this example, two diffusers are placed too close to each other. Their flow patterns will interfere and force supply air downwards, creating drafts in the occupied zone. 3. Undersupplying. In this case, there's a large room with only one diffuser supplying air. This situation will lead to poor air coverage throughout the room. In order to compensate for this, supply airflow will need to be increased, which will then lead to drafts in the occupied zone, large pressure drops, and higher noise levels. 4. Ceiling obstacles. This design shows a diffuser too close to a ceiling obstacle. The pattern of the diffuser will be disturbed and directed downwards, causing drafts in the occupied zone. A non-centered diffuser could also cause longer throws in one direction than another and potentially starve a section of fresh air. Good design. 1. Centered diffusers. Centering a diffuser in a room will ensure maximum coverage and throw. This is the correct method of locating the diffuser. 2. Diffuser spacing. Providing adequate space between the diffusers, at least a distance equal to double each diffuser's desired throw, will ensure that the diffuser's throws will not interfere with each other. 3. Undersupplying. When dealing with larger rooms, try to use more than one diffuser to supply air to the space. Believing that money will be saved by putting all the air through one diffuser will cause more problems in the future. 4. Ceiling obstacles. Generally, ceiling obstacles should never drop lower than 15 degrees below the edges of the diffuser. The discharged air will be affected by bulkheads or ceiling obstacles that do not follow this rule. Moving a diffuser away from the ceiling obstacle decreases the effect on the airflow. Problem solving. Buildings often have multiple zones that require different air conditioning needs due to local equipment, solar loads, room locations, the number of occupants, and their daily activities. For example, if we consider a building which experiences a lot of south-facing sunlight during the winter months, we can see that this building has multiple load demands. The south and east side of the building experience a greater solar load than any other portions of the building and will require a larger cooling period. The north and west walls will require a larger heating period as the solar load for these faces is smaller. VAV diffusers. If we imagine that this small office only has one rooftop unit and one thermostat, the system can only satisfy one of the cooling or heating calls. A VAV diffuser can be incorporated into each room to maintain proper thermal comfort without additional heating strategies. Automatic heat-cool changeover. Price VAV diffuser models that offer both VAV heating and VAV cooling are equipped with an automatic heat-cool changeover device. This device senses the diffuser's inlet air temperature, activating the heating mode if the supply air temperature is above 82 degrees Fahrenheit or 28 degrees Celsius, and activating the cooling mode if the temperature is below 71 degrees Fahrenheit or 21 degrees Celsius. The automatic heat-cool changeover feature allows Price VAV diffusers to seamlessly transition between modes. eliminating any need to adjust the diffuser to compensate for a change in supply air temperature. Perimeter zone reheat. Perimeter heat or radiant panels offer another solution to multiple demand spaces. The system can be designed so that the air handling unit supplies cool air to all diffusers and the perimeter radiation system be dependent on local thermostats. If the zone requires no further cooling, the VAV diffuser dampers will close and open if cooling is required, thereby satisfying the needs of all the building zones. Duct heater. Duct heater stations, an alternative to perimeter radiation or radiant panels, allow for thermal and ventilation demands in a large multiple demand zone system. For zones that require heating, instead of all the VAV diffusers closing when the air handling unit increases, the supply air temperature and the room temperature increases. Specific duct heater stations can energize to supply heat to the specific zones. The zones in which the VAV diffusers are within will automatically switch to heating mode if the option is selected, ensuring that there is adequate zone ventilation for each specific zone demand and allow the other zones to continue to function in cooling mode. A major drawback for duct heater station design is the additional energy costs required to cool, then reheat the air. Pressure control. System without VAV pressure control. It is important to control the system pressure for two main reasons. The first is to maintain design noise levels. If the pressure in the ductwork exceeds the design, the noise levels of the diffuser will increase beyond the design conditions when they throttle the air based on room load. The second reason is to prevent the DX coil on a rooftop unit from freezing over. Plenum bypass. Since this method involves bypassing air into the ceiling plenum, measures must be taken to remove the air, or the plenum space could become pressurized, which could result in air leakage through the return grills. The combination of exhaust fans with plenum static pressure sensors can control plenum pressure by dumping excess pressure outdoors. Another common method is to incorporate a pressure relief damper on the package rooftop unit. Ducted bypass damper. This method is similar to the plenum return method, except in this case you duct the bypass exhaust straight to the return ductwork. Methods to ensure that the plenum does not get pressurized must still be taken, such as an exhaust fan or rooftop relief damper, since the return ductwork can still become pressurized and bypass into the plenum. PRC, Price Pressure Relief Collar. Price pressure relief collars are a simple mechanical way of controlling system pressure. These collars have bypass gates that are forced open by a predetermined system pressure. When they open, air is bypassed into the ceiling plenum, thus reducing the pressure in the duct. VAV box control. The price pressure control valve, or PCV, is one method of controlling zone pressure. It operates using a signal from a static pressure sensor, which is located in the ductwork. When the static pressure increases above the desired levels in the zone, the damper will close off slightly, thereby reducing the amount of airflow that is allowed to enter the ductwork, which supplies the diffuser. Fan speed. Variable speed drive, or inlet vanes, are methods of fan control that can be used in conjunction with a static pressure sensor to reduce the total amount of air supplied to the controlled zones. Fan speed control units should not be used on rooftop units with direct expansion coils, as the lower flow could cause the coil to freeze over. Sizing of diffusers. To determine the correct size of diffuser for your application, first determine the maximum duct pressure in the system based on the pressure drop between the fan discharge and the farthest outlet. Using the modulated flow selection table for the appropriate VAV diffuser, find the design duct pressure that best matches the conditions. Select the inlet size that meets the specified sound criteria at the maximum design air volume. Check the throw values under these conditions to ensure they match the space requirements. Refer to the Air Distribution Guide in the Price Air Distribution Products catalog for more information on throw selection. Upon selection of the appropriate diffuser size, note the lowest air volume cataloged under the duct pressure column. This is the minimum limit of the diffuser at the listed static pressure. Assure that throw, noise, and air volume meet the required specifications. Varitherm. The Price Varitherm is the most advanced thermal power VAV diffuser available in the HVAC industry today. Using thermal actuators, the Varitherm provides superior occupant comfort and control by effectively regulating the supply of conditioned air to the space without use of electric or pneumatic controls. The Price Varitherm is an excellent choice for local VAV applications such as offices, boardrooms, and small zones. The Varitherm can also be used throughout a building as a primary VAV system. The Price Varitherm offers easy installation and operation, individual VAV zone control, room side access of all control adjustments, low pressure drop and quiet operation, ARI certified data, and heating and cooling or cooling only models. Varitherm features individual heating and cooling set points adjustable from the room, easy installation and balancing, balancing or force open mode, automatic heat-cool changeover, accurate linkage for exceptional performance in a variety of conditions, easily adjustable minimum airflow to satisfy ventilation requirements, and a 10-year warranty. Standalone technology. The Price Varitherm uses built-in thermal actuators that monitor supply and room air temperature and adjust an integral damper to vary the flow of conditioned air to the space. In heating mode, an increase in the room temperature beyond the room set point will cause the diffuser to decrease the amount of air delivered to the space, and a decrease in temperature beyond the room set point will cause a corresponding increase in air delivered to the space. In cooling mode, air induced over the thermal actuators will cause the damper to close as the temperature in the zone decreases, reducing the amount of cool air to the space. A rise in the room temperature beyond the room set point will cause a corresponding increase of cool air to the space. Cost-effective. The Varitherm is a cost-effective method to provide energy savings and increased thermal comfort through the creation of smaller zones. Traditional zoning strategies can fail to satisfy several occupants in a zone that supplies several offices. The Varitherm excels at delivering individual comfort by providing only the amount of warm or cool air to satisfy the local environment. This can lead to energy savings and give occupants a level of control previously only available with higher cost systems. Reliable performance. Price has a reputation for cataloging consistent and accurate performance data for our entire product line. The performance of the Price Varitherm is guaranteed by being ARI certified, a rarity for thermally powered VAV diffusers. User-friendly. The Varitherm is easy to install and use. Simply opening the plaque allows the user to make control adjustments. The plaque pivots securely on a solid hinge and is held closed by a set of powerful magnets. Easy-to-read gauges let you know what your settings are. Temperature is adjusted with the spin of a dial, and the minimum airflow setting is adjusted with the turn of a screw. The unit is also equipped with a forced open mode to assist in system balancing. All guidelines are simple and easy to follow and are written in a clear format on each unit. Optimal security fasteners mechanically lock the core into the back pan, where required by code. Retrofit. To help with trouble zones, the Varitherm is also available as a retrofit of our popular square plaque diffuser or square cone diffuser found in buildings across the continent. The Varitherm control module simply replaces the SPD or SCD core without the need to replace the back pan. Why choose the Price Veritherm over the competition? Price has carefully examined the industry's requirements for a thermally powered VAV diffuser. After years of research, our engineers have developed a reliable, low-cost, maintenance-free diffuser that offers the ultimate in personal comfort control. Let a Price representative show you why the Price Veritherm VAV diffuser should be your next choice for an independent personal comfort system. Conclusion. We hope that you've enjoyed this look at variable air volume diffusers. We've explored many of their aspects, including their concept of using self-modulating diffusers to monitor individual space conditions and adjust airflow to satisfy occupants' selected levels of comfort. We've compared the differences between VAV diffusers and conventional diffusers, and we've seen the numerous advantages that they offer. We've listed the benefits that can help achieve LEED certification. We've also examined operating principles that should be understood in order to design a successful VAV system. These include the Coanda effect, induction, ADPI, temperature measurement, diffuser layout, and pressure control. We covered how to design with variable air volume diffusers for buildings with multiple demand zones, using a variety of methods such as multiple air handling units, perimeter zone reheat, auto heat-cool changeover, and duct heaters. Finally, we've seen some of Price's product offerings in variable air volume diffusers like the cutting-edge Price Veritherm. For more in-depth information on this topic, you can always refer to the Price catalog. Be sure to check out the rest of the units in the Price training module to learn more about air distribution as well as the extensive line of Price products available. You can contact your local Price representative or visit our website at www.price-hvac.com for more information.